Hi everyone. In this lesson, we will talk about the difference between descriptive and inferential statistics. And we will also talk about some important definitions in statistics. The first thing I want to point out is the dataset. There are two main types of dataset: population and samples. Population is the complete set of all individuals or subjects that are being studied, and sample is a group of individuals or subjects selected from a population. We can kind of say sample is a subset of population. For example, let's say we take a survey of 430 students at the Aston University and ask them if they have ever used the services of the Learning Development Center. So we ask 430 students. So what is population? Aston students. So what is population here? All Aston students. And what is sample here? Those 430 students. So next thing I would like to talk about is the term in regards to population and samples. There are two important terms: a parameter and statistic. Parameter, it's the characteristic of population, and statistic is a characteristic of a sample. For example, if I say the average weight of 30 students, it's 67. So we have a group of 30 students, there are 30 students who's taking this statistic model, and I asked them their weight, and I found one average, and I found it as a 67 kilogram. This is parameter. If I say the average weight of 30 students is 67 kilogram, this is parameter. But if I say average weight of student is, I generalize it, 67 kilogram based on these 30 students, this is statistic, because by using little sample, I infer about the population. So if you obtain something by using the whole population, that is parameter. If you use group of people, sample, to obtain some information and infer about population, that is statistic. Another important definition in statistic is the type of the statistics, which is, first one is the descriptive statistic. So what is descriptive statistic? It is all about collecting, organizing, summarizing, and presenting data from samples. So what you do, you collect some data, you organize them, and then maybe you put them into a table or a chart and describe that data. You don't really try to draw too many conclusions from that data. You just present them. So, for example, if you ask 75 people about their favorite fruits, and imagine that 17 of them said it's banana, 25 of them said it's apple, 20 said strawberry, 6 said pear, and 7 said something else, some different fruits. As I said, and we create this pie chart to show the percentage by using those according to those 75 people. As I said, you just organize and describe the data that you have collected. And here is the pie chart showing the data that we collected from 75 people. And next one is inferential statistic. Inferential statistic is about generalizing from samples to population, performing estimation, hypothesis testing, determining relationship between the variables, and making some prediction. We use inferential statistic to form conclusion about large group, population, by collecting a portion of it as sample. Typically, because generally the population is so large that would be nearly impossible to obtain information about every item or person in it. Instead, what we do, we use selected people or items to collect information and then infer something about the population. Let's do some example. The average amount spent per gift for Mum and Mother's Day is £20 in the UK for the last Mother's Day. We cannot ask every single person in the UK how much they have spent for Mother's Day gift, if they bought any. If you can ask, that is population, but we can't because it's too big number. Instead, we collect some data from a subset of population called a sample. Maybe you ask 100 people, maybe ask 200 people, and obtain some values. Imagine that we obtain that average, and we generalize it and say it's £20. This is inferential statistic. This is inferential statistics. Okay. How about the mean household income for people aged 30 to 40? What do you think about this? This is, again, inferential statistic, as you cannot ask every person aged between 30 and 40 how much money they earn. Yeah, you create a sample, you use sample to get information, and then you generalize it. This is inferential statistic. How about a lecturer determines the average grade for the students in a particular course is 45%. This is descriptive statistic because you only give information about that group of students. You don't generalize it. We talk about a particular course. So this is descriptive. It doesn't infer or generalize something. How about the average cost of the main meal is £7 in the UK? This is again inferential because you generalize and you talk about the whole UK. This is inferential statistics. Probably you use some different food places, a couple of restaurants, maybe 10, maybe 20, maybe 30, to calculate the average, and you infer about the whole like a food chain. Okay, how about if we say the average cost of main meal is £12 at the XXX restaurant? If we talk about a specific restaurant, what do you think about this one? This is descriptive because I am talking about XXX restaurant for specific restaurant. I'm not generalizing it. I'm telling you the average meal costs £12 in that particular restaurant. So, what we have talked today, let's summarize what we have talked today. There are two major types of statistics, inferential and the descriptive. Descriptive statistic will only describe the data we have collected from group of people, and we don't draw conclusion about anything else. We don't infer about population. And inferential statistic is the type of statistic that would draw conclusion and infer about population. And what we also talk about, we define the population and the sample. When the population to be studied are really, really big, instead of the whole population, we use subset of population called samples to infer about the population.